Welcome to Syeadh Academy. Scheduling algorithms in operating system. Scheduling algorithms are an important component of an operating system, which manages the allocation of system resources to processes or threads. The main goal of scheduling algorithms is to improve system performance, throughput, and responsiveness. There are several scheduling algorithms used in operating systems. Some of the most commonly used scheduling algorithms include 1. First come, first serve scheduling. 2. Shortest job first scheduling. 3. Round-robin scheduling. 4. Priority scheduling. 5. Multi-level queue scheduling. 6. Multi-level feedback queue scheduling. First come, first serve scheduling. This is the simplest scheduling algorithm. In this algorithm, the process that arrives first is served first. However, this algorithm does not take into account the length of the process, and hence it can lead to poor response times for long-running processes. Shortest job first scheduling. This algorithm schedules the process with the shortest expected processing time first. This algorithm is optimal in terms of minimizing average waiting time, but it requires knowledge of the expected processing time of each process, which is not always available. Round-robin scheduling. This algorithm assigns a fixed time slice to each process in a round-robin fashion. If a process does not complete its execution within its time slice, it is preempted and added to the end of the ready queue. This algorithm provides good response time, but it may result in poor throughput if the time slice is too small. Priority scheduling. This algorithm assigns a priority to each process and schedules the highest priority process first. This algorithm is useful when some processes are more important than others, but it can lead to starvation of low-priority processes. Multi-level queue scheduling. This algorithm partitions the ready queue into several separate queues, each with its own scheduling algorithm. The processes are assigned to a queue based on their characteristics, such as CPU bound or input and output bound. This algorithm can provide good performance for different types of processes, but it is complex to implement and manage. Multi-level feedback queue scheduling. This algorithm is an extension of the multi-level queue scheduling algorithm. It allows processes to move between different queues based on their CPU usage and input and output requirements. This algorithm can adapt to changing workloads, but it is also complex to implement and manage. Conclusion. Each scheduling algorithm has its own advantages and disadvantages. The choice of scheduling algorithm depends on the specific requirements of the system and the workload.